Your gut wall is one cell thick. One. The barrier between the contents of your intestine, bacteria, toxins, partially digested food, and your bloodstream is literally a single layer of cells, each one sitting right next to the next, held together by structures called tight junctions. When those junctions fail, everything that's supposed to stay in your gut doesn't. It leaks through. And your immune system, which was never supposed to see any of that material, sees it and goes absolutely haywire. That immune response is chronic inflammation. And chronic inflammation is now linked to, not associated with, actually linked to, obesity, type 2 diabetes, autoimmune disease, depression, brain fog, joint pain, skin conditions, and fatigue that won't respond to sleep. Here's what nobody tells you. Most people dealing with any of those problems have never once been told to look at their gut lining, not their diet, not their sleep, their gut lining specifically. Because the mechanism that connects all of those conditions, the thread running through unexplained weight gain, stubborn belly fat, chronic tiredness, and constant low-grade inflammation, might literally be a structural failure at the cellular level. A failure that starts in your intestine and ends up affecting everything. That's what we're covering today. The full science of intestinal permeability, what it actually is, why it happens, what it does to your body, and the specific protocol that's been shown in clinical research to reverse it. This is life according to science. Let's get into it. Okay. First thing to understand, the name leaky gut is actually a clinical term now. For a long time, it wasn't. Mainstream medicine dismissed it. Doctors would look at patients who described bloating, fatigue, and brain fog and essentially say, "We don't know what's wrong with you. Your tests came back fine." The official term is intestinal hyperpermeability, and it's now documented in peer-reviewed research from Harvard Medical School, the Mayo Clinic, and the journal Cell Host and Microbe. It's real, and it's far more common than the medical establishment spent decades acknowledging. The gut lining replaces itself every 3 to 5 days. Leaky gut is what happens when that repair system fails. Here's the anatomy. Your small intestine is responsible for absorbing nutrients from food, amino acids, fatty acids, glucose, vitamins, minerals. Despite fitting into your abdomen, it has a mucosal surface area of roughly 30 square meters, about the size of half a badminton court, achieved through layers of folds, finger-like villi, and microscopic microvilli projections. That surface is lined with a single layer of epithelial cells. Between those cells sit tight junction proteins, specifically proteins called claudin, occludin, and zonulin. These proteins act like molecular zippers, holding adjacent cells together so tightly that almost nothing passes between them. Nutrients get absorbed through the cells themselves through controlled channels, not between them. Leaky gut is what happens when those tight junctions loosen, when the zippers open. And things start moving through the spaces between cells, things like lipopolysaccharides, which are fragments of bacterial cell walls, things like undigested food proteins, things like live bacteria. Now your immune system lines the gut wall. About 70% of your entire immune system lives in your digestive tract. It's called the gut-associated lymphoid tissue, and it is extremely good at one thing, recognizing foreign invaders. When those bacterial fragments and undigested proteins start crossing into the bloodstream, the immune system sees them as pathogenic threats. It triggers an inflammatory response. Cytokines get released. White blood cells mobilize. White. Your body goes into a low-level war footing. Except the threat never stops coming, because the gut is still leaking, so the inflammation never fully resolves. It becomes chronic, constant, low-grade, systemic. Scientists have a name for what happens when your immune system fights a war with no end, and it quietly destroys every organ in the process. Chronic systemic inflammation is not like the inflammation you get when you sprain an ankle, localized, acute, and resolved in days. This is inflammation throughout your whole body every day at a level low enough that you don't notice it as inflammation, but high enough that it's constantly damaging tissue, disrupting hormones, degrading metabolic function. And the worst part? Conventional blood tests rarely catch it. Most standard inflammatory markers, C-reactive protein, ESR, only spike in acute inflammation. Chronic low-grade inflammation can be actively destroying your health for years before it shows up on a standard panel. You go to the doctor feeling terrible. The tests come back normal. You walk out with nothing. So what breaks the tight junctions in the first place? There are 6 main drivers, and you need to understand them because at least 2 or 3 of them are almost certainly present in your life right now. The number 1 trigger is something doctors hand out like candy. Driver 1. Zonulin. This one is the most important mechanistically, and it's also the least known. Zonulin is a protein your body naturally produces. Its job is to regulate the tight junctions, to open them temporarily in controlled circumstances, to allow immune cells to pass through. The problem is that certain triggers cause your body to massively overproduce zonulin. When that happens, the tight junctions don't open briefly. They stay open. The 2 biggest zonulin triggers? Gluten and gram-negative bacteria in the gut. Research from Dr. Alessio Fasano at the University of Maryland School of Medicine. He's the scientist who identified and named zonulin in 2000. Showed that gliadin, a component of gluten, directly stimulates zonulin release in all humans, not just people with celiac disease, all humans. In most people, the effect is modest and temporary, but in people with a genetic predisposition or in anyone under sustained gut stress, it's amplified and prolonged. Zonulin is the molecular open sesame for your gut wall. Gluten is the voice that speaks it. Driver 2. Antibiotics. Here's the one that should concern you most if you've taken antibiotics at any point in the last 10 years. Antibiotics kill bacteria. That's the point. But they don't distinguish between pathogenic bacteria and the commensal bacteria that maintain your gut lining. Your gut microbiome, the roughly 39 trillion bacteria living in your intestine, plays a critical role in tight junction maintenance. Specific strains, particularly lactobacillus and bifidobacterium species, produce short-chain fatty acids called butyrate. Butyrate is the primary fuel for your colonocytes, the cells of the colon lining. When antibiotics wipe out those butyrate-producing species, the colonocytes starve. The gut lining literally thins. A single course of broad-spectrum antibiotics can reduce gut microbial diversity by up to 30%. Some of those species never fully recover. One course of antibiotics can permanently alter the bacteria guarding your gut wall. Most people have taken 3, 4, 5, or more. Driver 3. Chronic stress and cortisol. This is where the brain-gut axis becomes critically important. Your gut has its own nervous system, the enteric nervous system, containing over 100 million neurons. It communicates bidirectionally with your brain via the vagus nerve. When you experience chronic psychological stress, your hypothalamic pituitary adrenal axis stays activated. Cortisol stays elevated. Elevated cortisol does 2 things to your gut. First, it reduces blood flow to the intestinal lining, impairing cell turnover and repair. Second, it directly increases gut permeability by downregulating the expression of tight junction proteins. Animal studies have shown that psychological stress alone, without any dietary change, is sufficient to induce measurable increases in intestinal permeability within 24 hours. Think about what that means for someone under chronic work stress, financial stress, or relationship stress. Their gut is leaking, and it's leaking in direct proportion to their cortisol levels. Your stress and your gut lining are in a constant feedback loop. The worse your gut, the worse your stress response. The worse your stress, the worse your gut. Driver 4. Ultra-processed foods and emulsifiers. This is one of the more recent findings, and it's disturbing. Food emulsifiers, compounds like carboxymethylcellulose and polysorbate 80, which are used in almost every ultra-processed food to improve texture and shelf life, have been shown in research published in Nature to directly disrupt the mucus layer of the gut and alter the microbiome in ways that increase intestinal permeability. In a 2015 study, mice fed these emulsifiers developed low-grade gut inflammation and metabolic syndrome. Their gut bacteria had migrated closer to the intestinal wall, eroding the protective mucus layer. These are ingredients that are in your salad dressing, your protein bars, your packaged bread, your ice cream. They're generally recognized as safe. But safe in food regulation means they don't cause acute harm in a single serving. The research on what they do to your gut lining over years of daily consumption is a different story entirely. Driver 5. NSAIDs, ibuprofen, naproxen, aspirin, the drugs most people take reflexively for headaches, muscle pain, and inflammation. Non-steroidal anti-inflammatory drugs directly increase gut permeability. This has been documented consistently in research since the 1980s. NSAIDs inhibit prostaglandin synthesis, and prostaglandins are critical for maintaining the integrity of the gut mucosa. Studies using lactulose mannitol tests, the clinical gold standard for measuring intestinal permeability, show measurable increases in gut leakiness within hours of NSAID ingestion. Every time you take ibuprofen for a headache, you are measurably increasing your gut permeability. The drug you take for inflammation might be the thing causing the inflammation in the first place. Driver 6. Alcohol. Alcohol is directly toxic to enterocytes, the epithelial cells lining your intestine. Alcohol metabolism in the gut produces acetaldehyde, which disrupts tight junction proteins and increases gut permeability. Chronic alcohol use dramatically increases circulating endotoxin levels, bacterial fragments in the bloodstream, which is why alcoholic liver disease looks mechanistically similar to leaky gut syndrome. Interestingly, even moderate alcohol consumption, 2 drinks per day, has been shown to produce measurable increases in intestinal permeability in some individuals. This is where it gets really important, because most people think of leaky gut as a gut problem, a digestive issue, bloating, gas, maybe some food sensitivities. That's not the threat. The threat is what happens downstream when endotoxins, specifically lipopolysaccharides or LPS, which are fragments of gram-negative bacterial cell walls, start circulating in your bloodstream every day. LPS in your bloodstream triggers the exact same immune response as a bacterial infection, except it never stops. Effect 1. Insulin resistance. This is the mechanism most people have never heard of, and it may be the most consequential. When LPS enters the bloodstream, it binds to toll-like receptor 4, TLR4, on immune cells and on fat cells and on muscle cells. When TLR4 on a fat cell gets activated, it triggers a signaling cascade that includes the activation of a molecule called IKK-beta. IKK-beta directly phosphorylates, meaning it deactivates, the insulin receptor substrate, the molecular machinery that allows insulin to signal cells to take up glucose. In plain terms, the LPS from your leaky gut is physically blocking your cells from responding to insulin. This is insulin resistance, not from too much sugar, not from overeating. From bacterial fragments crossing through your gut wall. 2 key studies establish this. In humans, a study published in the Journal of Clinical Endocrinology and Metabolism showed that intravenous LPS infusion in healthy volunteers produced measurable insulin resistance within hours. In a landmark 2007 mouse study published in the journal Diabetes, Canny and colleagues showed that continuous low-dose LPS infusion was sufficient to produce obesity, elevated fasting insulin, and insulin resistance to a similar degree as a high-fat diet, without any change in food intake. Mouse studies show LPS infusion alone, no change in diet, no extra calories, produced obesity and insulin resistance equivalent to a high-fat diet. Human studies confirm LPS produces insulin resistance within hours. The source of the LPS? A leaking gut. Effect 2. Fat storage and weight gain. Insulin resistance doesn't just mean blood sugar problems. When your cells stop responding to insulin, your pancreas compensates by producing more insulin. Chronically elevated insulin is one of the most potent signals for fat storage in the human body, particularly visceral fat, the fat that accumulates around your organs. So the cycle looks like this: leaky gut to LPS in bloodstream to TLR4, activation to IKK-beta, to insulin receptor blockade, to insulin resistance, to compensatory hyperinsulinemia, to visceral fat accumulation. And visceral fat is not passive. It's metabolically active. It produces its own inflammatory cytokines, TNF-alpha, IL-6, IL-1-beta. Those cytokines circulate back to the gut and increase intestinal permeability further. You now have a closed loop. Leaky gut causes the inflammation that causes the fat gain that causes more inflammation that causes more gut damage. Breaking this loop requires addressing the gut first, not the diet, not the calories. The gut. Visceral fat isn't just storing energy, it's actively secreting the chemicals that make your gut leak more. Effect 3. Chronic fatigue and brain fog. LPS doesn't just affect metabolic function, it crosses the blood-brain barrier. Not in large quantities, your blood-brain barrier is fairly well defended against LPS. But chronically elevated LPS levels trigger systemic cytokine release, and those cytokines do affect the brain. Specifically, they activate microglial cells, the brain's resident immune cells. Chronic microglial activation is now associated with neuroinflammation, impaired neuroplasticity, disrupted neurotransmitter synthesis, and cognitive dysfunction. The symptoms look like depression and brain fog, difficulty concentrating, memory issues, low mood that doesn't respond to lifestyle changes because the cause isn't psychological, it's inflammatory. There's a clinical term for the behavioral and cognitive changes caused by inflammatory cytokines: sickness behavior. It was originally studied in the context of acute infections. Researchers are now finding evidence that chronic low-grade endotoxemia produces a milder but persistent version of the same state. You're not burned out. You're inflamed. Depression and fatigue that don't respond to therapy or lifestyle changes might not be in your head at all. They might be in your gut. Effect 4. Autoimmune disease. This is the mechanism that Dr. Fasano's research has focused on most heavily in recent years. The current leading hypothesis for autoimmune disease, conditions like rheumatoid arthritis, Hashimoto's thyroiditis, lupus, multiple sclerosis, is called the 3-hit hypothesis. Hit 1, genetic predisposition. Hit 2, an environmental trigger, a virus, a toxin, a food antigen. Hit 3, intestinal hyperpermeability. The argument is that having a genetic predisposition and an environmental trigger is not sufficient to develop autoimmune disease on its own. The trigger can only access the immune system at the scale required to initiate autoimmunity if the gut barrier is compromised. Leaky gut is the gatekeeper. It's the thing that lets the trigger in. If this model is correct, and the evidence is increasingly strong, then healing the gut lining is not just about digestion. It's potentially about preventing autoimmune disease from triggering in the first place, or about reducing the severity of an autoimmune condition that's already active. The gut wall might be the last line of defense between your genetic predispositions and the diseases they could become. Effect 5. Histamine intolerance and food sensitivities. This is one of the less discussed downstream effects, but it's extremely common clinically. When the gut lining is damaged, the enzyme diamine oxidase, DAO, which is responsible for breaking down histamine in the gut, gets reduced. Histamine from food accumulates. Combined with the increased permeability allowing food antigens to reach the immune system directly, you get widespread and often seemingly random food sensitivities. People develop reactions to foods they previously tolerated. They do elimination diets and feel somewhat better. They add foods back and react again. They can't figure out the pattern because the problem isn't specific foods. It's the gut lining that's failing to process anything properly. There are several ways to assess intestinal permeability, ranging from clinical tests to symptom patterns. There's a test that tells you exactly how leaky your gut is. Your doctor probably hasn't mentioned it. The lactulose mannitol test. This is the most validated clinical test for intestinal permeability, and it works like this. You drink a solution containing 2 sugars, lactulose, which is a large sugar molecule that should not be absorbed by the gut in significant amounts, and mannitol, a small sugar molecule that is readily absorbed through normal transcellular channels. After drinking the solution, urine is collected for 6 hours. In a healthy gut, you'll see very little lactulose and a normal amount of mannitol in the urine. In a leaky gut, lactulose gets through the paracellular gaps and shows up at elevated levels. The ratio of urinary lactulose to mannitol is your intestinal permeability index. Some functional medicine practitioners use this test regularly. It's not standard in conventional medicine yet, though it's widely used in research settings. Zonulin blood test serum. Zonulin can be tested via standard blood draw. Elevated zonulin is a direct marker for tight junction disruption. The normal reference range is under 100 nanograms per milliliter in most labs. Levels above 150 are clinically significant. This test has become more accessible as functional medicine has grown, and some conventional gastroenterologists now order it. LPS antibody testing. Some panels test for antibodies to LPS, specifically IgA, IgM, and IgG antibodies to lipopolysaccharides. Elevated antibody levels indicate that your immune system has been mounting responses to LPS that entered the bloodstream, which means your gut has been leaking LPS into your circulation. Clinical symptom patterns. If you don't have access to testing, clinical symptom patterns are highly suggestive. A combination of the following warrants investigation: chronic bloating or gas, particularly after diverse foods, rather than specific ones; persistent fatigue not explained by sleep quality; brain fog, difficulty with working memory; low-grade depression, multiple food sensitivities that seem to be expanding over time; skin conditions, eczema, psoriasis, acne, particularly those that respond to gut-focused interventions; joint pain without clear mechanical cause; any diagnosed autoimmune condition; unexplained weight gain concentrated around the abdomen despite reasonable diet. This is where most videos stop at generalities. Eat more fermented foods. Take probiotics. We're not doing that. This is the evidence-based protocol. Every intervention here has research support in human subjects or well-replicated animal studies. And every mechanism is explained so you understand why it works, not just that it works. The protocol has 4 phases, and the order matters. Most gut healing protocols fail because they skip phase 1 entirely. They try to rebuild before they've stopped the damage. Phase 1. Remove the triggers. Weeks 1 to 4. You cannot heal a wound that keeps getting injured. Phase 1 is entirely about removing the inputs that are driving tight junction disruption. Remove emulsifiers and ultra-processed foods. Read every ingredient label. Eliminate anything containing carboxymethylcellulose, polysorbate 80, carrageenan, soy lecithin, or any ingredient ending in cellulose. These are the most studied emulsifiers with documented effects on gut permeability. This means cooking from whole ingredients for the majority of your meals. Not because of calories, because the food additives in processed foods are functionally toxic to the gut lining. Minimize NSAID use. If you're taking NSAIDs regularly, even low-dose aspirin daily, discuss alternatives with your doctor. For acute pain, consider whether the dose and frequency can be reduced. Paracetamol does not increase gut permeability and is a reasonable alternative for many uses. Alcohol reduction or elimination. The research is fairly clear that even moderate alcohol consumption impairs gut barrier function in susceptible individuals. For the purposes of a healing protocol, elimination for the first 4 weeks is the most effective approach. If that's not realistic, reducing to 1 or fewer drinks per week substantially reduces the acetaldehyde-mediated tight junction disruption. Address gluten strategically. You don't need to go gluten-free forever if you don't have celiac disease. But during an active healing protocol, significantly reducing gluten intake reduces zonulin stimulation and gives the tight junctions the opportunity to recover. Many people are surprised how significantly their symptoms change within 2 to 3 weeks of gluten reduction. Not because gluten is inherently evil, but because it's mechanistically the most direct driver of zonulin release. Phase 1 isn't a diet, it's surgery. You're removing the tools that are actively cutting the gut open. Phase 2, restore microbial diversity, weeks 3 to 8. The microbiome and the gut lining are in a mutual support relationship. A healthy, diverse microbiome produces the short-chain fatty acids that fuel the gut lining's repair. A healthy gut lining provides the environment for a diverse microbiome to thrive. When both are damaged, you have to rebuild both simultaneously. Butyrate-focused prebiotics. The single most important nutritional intervention for gut lining repair is increasing the production of butyrate. Butyrate is the primary energy source for colonocytes. It also has direct anti-inflammatory effects, inhibiting NF-κB signaling, one of the master switches for inflammatory gene expression. The way to increase butyrate is not to consume it directly. It's largely metabolized before it reaches the colon. The way to increase it is to feed the butyrate-producing bacteria with their preferred substrates. Those substrates are resistant starch and fermentable fiber. Resistant starch sources: cooked then cooled rice, cooked then cooled potatoes, green bananas, legumes. When you cook starch and let it cool, the molecular structure changes. It becomes resistant to digestion in the small intestine and reaches the colon intact, where bacteria ferment it into butyrate. High fermentable fiber vegetables: Jerusalem artichoke, chicory root, garlic, onion, leek, asparagus. These contain inulin and fructooligosaccharides, the preferred fuel for bifidobacterium, one of the key butyrate-producing genera. Clinical recommendation: 20 to 40 grams of diverse fermentable fiber per day. Most people in Western countries consume 10 to 15 grams. You need to double or triple your intake gradually. Too fast causes significant gas production as your microbiome adjusts. Cooled rice has a different molecular structure than hot rice. It's not the same food to your gut bacteria. Probiotics. The specifics that matter. Not all probiotics are created equal, and most probiotic supplements on the market have insufficient evidence for gut barrier repair specifically. The strains with the most robust research for intestinal permeability. Lactobacillus rhamnosus GG, the most studied probiotic strain with multiple randomized controlled trials showing improvements in tight junction protein expression. Lactobacillus plantarum, shown to increase claudin-1 and occludin expression in human studies. Those are the actual tight junction proteins. Bifidobacterium longum, shown to reduce intestinal permeability and circulating LPS levels. Saccharomyces boulardii, a probiotic yeast with strong evidence for reducing intestinal inflammation and improving gut barrier function, particularly in the context of antibiotic-associated gut dysbiosis. Look for supplements that contain at least 2 of these specific strains, or consume fermented foods that naturally contain them. Yogurt with live cultures, kefir, kimchi, sauerkraut, miso. The research on fermented foods, specifically, was compelling enough that a 2021 Stanford study published in Cell compared high-fiber diets to high-fermented food diets across 36 healthy adults over 10 weeks. The fermented food group showed increased microbiome diversity and a measurable decrease in 19 inflammatory proteins, including IL-6. The high-fiber group showed no change in inflammatory markers and no increase in microbiome diversity. A Stanford study published in Cell found that fermented food reduced 19 inflammatory proteins in 10 weeks. The high-fiber group saw zero reduction in inflammatory markers. Most people have never heard of this study. Phase 3. Provide targeted gut lining nutrients, weeks 4 to 12. Visual, supplement, and food source infographic. Once you've removed the triggers and started rebuilding the microbiome, you can accelerate gut lining repair with specific nutrients that have direct evidence for supporting tight junction integrity. L-glutamine is the primary fuel source for enterocytes, the cells of the small intestinal lining. Unlike colonocytes, which run on butyrate, enterocytes run almost exclusively on glutamine. In states of gut barrier compromise, demand for glutamine exceeds what the body can synthesize. Supplementing directly supplies the raw material the gut lining needs to repair itself. The research on glutamine is solid. Multiple studies in critically ill patients who have extremely high gut permeability due to physiological stress show that glutamine supplementation measurably reduces intestinal permeability and the translocation of bacteria. Clinical doses used in research, 5 to 10 grams per day, taken on an empty stomach to maximize delivery to the intestine rather than systemic use. Food sources with high glutamine content: bone broth, red meat, eggs, and dairy products, particularly raw or minimally processed dairy. Your gut lining cells run on glutamine the way your brain runs on glucose. A deficiency literally starves the repair process. Zinc carnosine. Zinc carnosine is a chelated compound of zinc and carnosine that has unique properties for gut lining repair that neither zinc nor carnosine provides individually. It has a specific affinity for the gastric and intestinal mucosa, adhering to the lining and exerting local anti-inflammatory and repair effects. A human clinical trial published in the journal Gut in 2007 found that healthy volunteers taking zinc carnosine at 37.5 milligrams twice daily, alongside an NSAID that is known to increase gut permeability, showed no significant increase in intestinal permeability, while the placebo group experienced a threefold increase. That's not a modest protective effect. The compound essentially blocked the NSAID's ability to open the gut lining. Without zinc carnosine, the gut leaked 3 times as much. With it, permeability remained stable. This is a specific intervention, not just general zinc supplementation. Collagen and glycine collagen is the structural scaffold of the gut lining. The extracellular matrix underlying the epithelial cells is largely composed of collagen type 4. Glycine, the most abundant amino acid in collagen, has direct anti-inflammatory effects. It inhibits NF-κB activation and reduces cytokine production. Bone broth is the most bioavailable dietary source of both collagen and glycine. Research isn't as robust for bone broth specifically as for isolated nutrients, but the mechanistic rationale is strong and the clinical evidence accumulating. If supplementing, collagen peptides at 10 to 15 grams per day or glycine at 3 to 5 grams per day. Take with vitamin C, which is a cofactor for collagen synthesis. Vitamin D receptors are expressed throughout the gut, and vitamin D has been shown to directly regulate the expression of tight junction proteins. Deficiency, which is extremely common, with estimates suggesting 40% of adults in northern latitudes are deficient, is associated with increased intestinal permeability. Multiple studies have shown that correcting vitamin D deficiency improves gut barrier function. The research is particularly strong in inflammatory bowel disease, but extends to general intestinal hyperpermeability. Target serum 25-hydroxyvitamin D, 50 to 70 nanograms per milliliter for optimal gut barrier function. significantly higher than the conventional normal range of 20 to 30. Quercetin. Quercetin is a flavonoid found in high concentrations in capers, red onions, and apples. It has direct evidence for increasing tight junction protein expression, specifically increasing claudin-1 and occludin in both cell studies and animal models. A 2016 study in the journal Tissue Barriers showed quercetin supplementation at 500 milligrams per day significantly restored gut barrier function in a model of intestinal permeability. Human trials are smaller but consistent in direction. The compound in red onions that makes your eyes water is the same compound that zips your gut lining back together. Phase 4. Nervous system. Regulation ongoing. This is the phase most protocols omit entirely. It's also the phase that determines whether you maintain your results long term. Remember, chronic stress via the cortisol axis directly increases gut permeability. If you've healed your gut lining with phases 1 through 3, but you're still operating in a chronic stress state, the lining will continue to be damaged. The intervention target here is vagal tone, the activity of the vagus nerve, which mediates the parasympathetic regulation of the gut. Vagus nerve. Activation practices diaphragmatic breathing, specifically the 4-7-8 pattern. Inhale for 4 counts, hold for 7, exhale for 8. Activates the parasympathetic system via vagal afferents. Practiced for 10 minutes daily, research shows measurable increases in heart rate variability within 6 weeks, which is a direct proxy for vagal tone. Cold water exposure. Brief cold exposure, 30 to 90 seconds of cold water at the end of a shower, activates the diving reflex, which stimulates the vagus nerve and increases parasympathetic tone. Gargling and humming. These activate the muscles of the posterior pharynx, which are innervated by the vagus nerve. Sounds odd. Works. Zone 2 cardiovascular exercise, low-intensity aerobic exercise performed at approximately 60 to 70% of maximum heart rate for 30 to 60 minutes, 3 to 5 days per week. This is the exercise intensity at which parasympathetic tone is maintained rather than suppressed. It also directly reduces circulating cortisol and inflammatory cytokines. Exercise is part of the gut healing protocol, not for the calories, for the cortisol reduction and vagal tone restoration that makes the rest of the protocol stick. Realistic expectations matter here because if you expect to feel dramatically better in a week and you don't, you'll abandon the protocol before it can work. Weeks 1 to 2. Some people experience a temporary worsening of symptoms as the microbiome shifts. Increased gas and bloating as fermentable fiber intake increases. This is normal and resolves. Weeks 2 to 4. Most people notice some reduction in bloating and improved digestion as triggers are removed and the microbiome begins to stabilize. Weeks 4 to 8. Measurable improvements in energy and cognitive clarity as systemic LPS levels begin to fall and chronic microglial activation reduces. Food sensitivities may start to narrow. Weeks 8 to 16. Significant improvements in metabolic markers, fasting insulin, inflammatory markers in people who had elevated levels. Body composition can begin to shift as insulin resistance improves. 3 to 6 months. Full structural repair of the gut lining in most people following the complete protocol. This is the time frame used in clinical research studies. The gut lining replaces itself every 3 to 5 days. But it took years of damage to get here. Respect the 6-month timeline. Mistake 1. Jumping straight to probiotics. Shao. Probiotics into a dysbiotic inflamed gut without first removing the triggers is like trying to seed a garden in contaminated soil. The new bacteria can't establish in an environment that's still actively hostile. Phase 1 has to come first. Mistake 2. Going too fast on fermentable fiber. Suddenly adding 40 grams of inulin and resistant starch to a gut that's been running on low-fiber processed food causes significant gas, bloating, and cramping. The microbiome adaptation takes time. Increase fiber by 5 grams per week, maximum. Mistake. 3. Relying on supplements without dietary change. L-glutamine, zinc carnosine, and quercetin are powerful interventions. They are not powerful enough to overcome continued daily consumption of emulsifiers, alcohol, and NSAIDs. The protocol is layered. Supplements in Phase 3 work because Phases 1 and 2 were executed first. Mistake 4. Ignoring stress. This is the most common failure mode for people who do everything else right and still don't see sustained results. If cortisol remains chronically elevated, gut permeability remains elevated. Full stop. Phase 4 is not optional. Rehook. You can take every supplement on the list and still have a leaky gut if your cortisol is chronically elevated. Stress is a direct physiological driver of intestinal permeability. Foods that support gut barrier repair: fermented foods, kefir, sauerkraut, kimchi, miso, yogurt with live cultures, resistant starch, cooled cooked rice, cooled cooked potatoes, green bananas, legumes, prebiotic vegetables, Jerusalem artichoke, asparagus, garlic, leeks, onions, glutamine-rich foods, bone broth, eggs, meat, zinc-rich foods, oysters, pumpkin seeds, beef, chickpeas, quercetin sources, capers, red onions, apples with skin, green tea, omega-3 rich foods, fatty fish, walnuts, chia seeds, anti-inflammatory, and support tight junction integrity, collagen sources, bone broth, skin-on poultry, oxtail, foods, and compounds that damage. Gut barrier function. Emulsifiers: carboxymethylcellulose, polysorbate 80, carrageenan. In most ultra-processed foods, alcohol, particularly in daily or near-daily quantities, NSAIDs, ibuprofen, naproxen, aspirin, gluten, specifically during active healing phases. Refined fructose and high fructose corn syrup promotes dysbiosis and increases gut permeability. Artificial sweeteners. Some evidence that saccharin, sucralose, and aspartame negatively alter microbiome composition. Your gut wall is 1 cell thick. That was where we started. And the reason that matters is this: that single cell layer is not just about digestion. It's the gatekeeper between the microbial world in your gut and everything else in your body: your bloodstream, your immune system, your brain, your metabolic function. When it fails, the failure is quiet. It doesn't show up on standard blood tests. It doesn't announce itself with a dramatic diagnosis. It leaks slowly into chronic inflammation, insulin resistance, brain fog, unexplained weight gain, food sensitivities, fatigue, and eventually, in some people, full autoimmune disease. When it heals, the recovery is also quiet at first. Then one day you realize you're not bloated after every meal. Your energy doesn't crash at 3 p.m. Your brain works. Your food sensitivities are narrowing. Your fasting insulin is lower. Your weight is moving without you understanding why, because you haven't changed your calories. What changed is the gate. The gut wall is 1 cell thick. But those cells and those tight junctions are doing more work than almost any other structure in your body. Treat them that way.